Have you ever wondered how the sun glows? Well, about to find out. Hope you enjoy. So, before we can understand where the energy and light come from, we have to inspect the different layers of the sun. The sun is comprised of 7 distinct different areas: the core, the radiation zone, the convection zone, and the photosphere. Like our planets, and any celestial body that has enough gravity to hold gases around it, it also has its own atmosphere as well, comprised of chromosphere and the corona. Starting from its core, we can observe a bunch of little hydrogen friends. Although the outer layers are a lot cooler, I still wouldn't want to go anywhere near it. The inner core of the sun can be about 15 million Kelvin. That is millions and millions of degrees Fahrenheit. As a star initially formed by starting as a cloud of gas, hydrogen, gravity over a long period of time caused it to compress, and this made it become really dense. Inside of this density and heat, trillions of hydrogens are colliding to form helium, which shoot off gamma photons, which is precisely the energy that is coming out of this nuclear reaction. But what happens when it runs out of helium? Well, there's no more coal, as it may, to fuel the reaction of energy anymore, and the sun will burn out. But we have a lot of time before that happens, like billions of years more. So how do these gamma ray photons, the energy made out of the reaction, get out into space? This is caused by an occurrence called hydrostatic equilibrium. And this is where the outward pressure from the energy produced from the nuclear fusion push against the inward pull of gravity, trying to collapse the sun. So it's gravity pulling everything towards the center and fusion energy pushing it outward. This is how the sun's structure remains stable and continues to emit these photons of energy by constantly creating helium from hydrogen. So, let's look at the sun's layers once more. We have the convection zone and the radiative zone. The radiative zone is where energy moves by this radiation produced from the gamma coming from the core's nuclear reaction, and photons are emitted but also absorbed. These photons can take millions of years to get out because they are constantly trying to get involved with these trillions of reactions going on inside. The convection zone, which is further from the core, causes boiling-like motion because it is cooler, since there is less energy while the reaction is happening within the core. As a result of this ongoing nuclear reaction, there is also plasma, which is a state of matter created that will sit within this zone and is also the cause of the photosphere appearing as it's moving around. Well, that's been Why the Sun Glows. Thanks for watching.